Hello, and welcome back to our tutorial on Nanolyzer. In this video, we're going to go through some custom filtering operations. So these are advanced filtering operations where you can start to select subsets of events based on much more complex criteria than just the simple metadata numbers that we demonstrated in the previous video on data filtering. So aside from that basic filtering stuff, Nanolyzer allows for more complex filtering, and you could create these using SQL queries directly. Now, using these effectively requires that you understand a little bit about how data is organized behind the scenes. So we'll cover some of that. And you can always check the help link here in the data manager if you need a refresher. And we'll cover that a little bit in more detail later. Suppose you have a complex data set that has events with multiple sublevels, and you want to select the subset of events that contains a particular sublevel at a particular position in the event. For the sake of illustration, we'll demonstrate how to select the subset of our events that begin with a folded DNA translocation level. And then we'll unpack some of the SQL behind it to help you understand how to build your own filters. So we'll start by refreshing how to label sublevels using the clustering tools. So you can check out the dedicated video on clustering for more detailed overview of this part, but for now, we'll just head over to the clustering tab. And we'll select the metadata that we're going to use to do our clustering. And for this one, we're going to use sublevel duration, sublevel blockage, and we're also going to use the number of levels and add this to the plot. So once you've selected those, hit update sublevels. We're going to use HDD scan. And you'll see that we've identified 4 clusters here. The sublevel labeled 0 in blue is the unfolded level in events that don't contain a fold, so single file passage all the way through. The sublevel labeled 1 in orange is the folded level in events that contain 4 sublevels. Remember, this includes 2 baseline levels, so that would be an unfolded level in a partially folded event. The sublevel labeled 2 in green is the folded level in events that are completely folded. And finally, the red sublevel labeled 3 is the folded level in events that are partially folded. And so just through a couple of clicks, we've really broken down our sublevels into exactly what they mean within each event. And this is relatively simple to do. So now let's use these labels to build the subset of events that begin in the folded state and then go back to the unfolded state before exiting the pour, which means these are events that have sublevel 3 as their first block state. To do this, we'll go over to the data manager and we'll select CU for custom operation. I've already built the filter I need, and we'll see the effect, and then we'll unpack what's going on. But generally speaking, you can just copy paste this text into the custom operation box, and away you go. So for simplicity, I've deleted the other subsets that we've previously defined in the other videos, so we don't make our workspace too cluttered. But right now, I'm just going to select my folded first filter, which builds my SQL query here. I'm going to call this folded first, and I'm going to filter and make subset. And we can go back and we can see the results in our stats tab, for example. We have events just satisfying this folded first criteria, which appear exactly where you'd expect to on the dwell time versus max blockage plot. We can then look at sublevel blockage, for example, and we see that these are spread out now where we're looking at events explicitly that have 2 levels, and so we'd expect to see sublevels appear in both the folded and unfolded states. And we can also go over to the event viewer. We can select our folded first sublevel, and we can just flip through, and we see that this is exactly what we think it is. These events all start in the deep state and end their residence in the unfolded state. And so with just a few clicks, we've picked out a very specific subset of the events that we fitted before, and now we can do whatever we need to with those. So let's unpack this. To understand what's going on, we need to take a look at the data tables behind the scenes. So to do this, I'll save our subset. I'll save the full data set for the sake of illustration. And this is just simply giving me an error here because I've already saved all of this. And we can open up the Sublevels table right here. So we can see a whole bunch of columns defined in this Sublevels table. So IDX, this is just a count associated with the levels in the subset, just counting up from 0. ID is a non-unique label that's used across all of Nanolyzer to associate information across tables. So ID 0 refers to event 0, and then each entry, each row with ID 0 corresponds to a sublevel within event 0 in this case. Then this breaks out into the currents, the durations and the blockages and noise associated with each sublevel. And then we move on to level num and levels left columns, which just refer to the index of the sublevel within an event. So the first baseline state has level num 0, the first block state has level num 1, and the next block state 2, and so on, and then it resets for the next event. Levels left just goes in reverse order, which lets you reference sublevels in order from either the start or the end of an event. And sublevel label now refers to the labels that we assign each of these sublevels during our clustering. So a label of -2 means a baseline state. A label of -1 means an outlier, and 0 and all positive integers and 0 refer to the sublevels that we defined in the clustering. And note that this column is only defined if you have previously used clustering to identify these sublevels. Sublevel confidence refers to essentially what it sounds like, how confident the clustering analysis is that that level belongs to the label that it was assigned. So let's look at what our query is actually doing with this information. And to do this, basically in here, we're defining two lists, ID and IDX from the sublevels table where level num equals 1. So this gives us the ID and IDX columns for all of the first block state from the table I just showed you. The second one here gives us the same information for all of the entries in that table that contain or that correspond to sublevels labeled 3, this folded state in the partially folded configuration that we'd previously defined. And finally, we interjoin these two subsets using ID, or IDX rather, which essentially means that we are just keeping the subset of IDs that appear in both of those lists. And at the end of this, essentially, we have a list that corresponds to all of the IDs and IDXs that have a sublevel label 3 in the level position level num equals 1, which is to say we have a list of IDs corresponding to all of the events that have a block state, or sorry, that have a folded state in the first blocked position, which is exactly what we want. Finally, we wrap that in the ID in clause, which just tells Nanolyzer that we want a complete set of metadata available for all events whose ID is in that list we just defined, and that gives us our complete filter operation. Now, building these filters the first few times is a bit tricky, but once they're built, you can reuse them easily. Remember, you can always save your filters and then reload them later. And there will be a link to a blog post below where you can see a few more examples of filtering of this kind. And you can use those as a base to build your own. You can edit them quite easily to tune them to whatever your application is. If you need to see the table structure of Nanolyzer, you can always click the help link here. We'll pop open this helpful intro that gives you information on basic SQL syntax, SQL query construction, gives you a list of all of the variables as well as the tables that they correspond to. And you can use those again to build out filters. You have an SQL reference that lets you take a look at all of the mathematical functions available to you, because you can apply mathematical functions inside your filter operations. And finally, a notepad where you can simply save notes and scratch work as you construct these filters. We're also always happy to help you get started, so don't hesitate to reach out if you need help defining the perfect filter for your analysis task. And thanks for watching. Looking forward to seeing what you're able to do with these tools.